Okay, good morning everyone. I think I can start the class now. Hope you have a great spring break. And I have to let you know some things, some important things about next week. Okay, this week we will have two online. I will have some assignment. You can see on the screen. Regarding the online homework, you have the online homework 8.1 and 8.4 during this week, and you will have the handling homework 5, not 5, 6. I will post on Canvas soon. Okay, and due next week, and on Friday next week, April 1, we will have the test. Okay, this is test 3. In this step, it's cover the chapter 7, chapter 8, and a part of chapter 10. Okay, that's all I think. And you will do the test at home, similar to the first step and the second test, things like that. And I will also give you the sample test for this. Okay. Any question? Okay. That's all the things about the information about the test, assignment, something like this. Okay. And now we will move on to the chapter 8. Chapter 8. Okay, estimating the population parameters. Okay. And in the previous chapter, we learned about how to measure the information, something like the mean, standard deviations, about the sample, right? The sample statistic. But the thing is, we need the information about the population. We need about information about population. For example, when we make the investigations about the GPA of students at West State University, we cannot survey all the students at West State University, right? We just do in the small group or small sample. For example, I just do the survey in my class or in some classes. I cannot do the survey for all students, or I cannot ask all the students at West State University. So if I know the information about the sample, like I know the means about the sample, I know the standard deviation about the sample. So what will I get if I know the information about this? How do I know about the population mean? How do I know about the population proportion? Something like this. How do I know if I know about the sample mean? I know about the sample standard deviation. Something like this. Okay. So today we will know how to do this. We will know how to estimate the population mean. Okay, that is the thing when we make the decision about this. Okay, here is an example. A television network may want to know how many Americans watch its TV show each week. Okay, it is impossible to survey each and every household. Okay, and but we can survey a small group, or we can survey samples, and after that we can make the decision when we survey the sample. Okay, and the thing here is we will the purpose of this lesson here is we will use the information to estimate the population mean. Okay, and we have two kind of estimate. The first thing that is the point estimate. Okay, and the second one is the interval estimate. The first one here is sometimes is not exact method. Okay, and the second one here is better than the first one. Okay, I will give you the definition about this. The point estimate is a single number estimate of a population parameter. Okay, for example, I assume that the population mean is 29, for example, like this. And I will estimate the mean here is approximately 28. This is the point estimate. I give one number for the population mean. That is the point estimate. Okay, clear, right? That is the point estimate. When regarding the point estimate, I will give the exact number, one number for this, for the population mean or order. That called the point estimate. Point estimate. That means. And unbiased estimator is a point estimate that does not consistently underestimate or overestimate. For example, you see that the population mean here is 29, for example, and I get the number is 28. So that is called unbiased. If I get the number like 19, something like this, so it's very underestimate, right? So that is called biased estimator. Or I get the mean here is 40, something like that. So that's called the overestimate. Or that is biased estimator. And if I get the number is very close to 29, for example, 28.5, something like this. So that's called unbiased estimator. Okay? Clear, right? Okay. But the disadvantage of this method is if we use the single estimate for estimate the population parameter, we will leave a lot of room for error. We will let a lot of error, even if the statistic is an unbiased estimator. Sometimes we will not use point estimate. We often will not use. But it will play a crucial role in another one, not for estimate. But we will use this to estimate the interval estimate. Okay. Okay. What about the interval estimate? An interval estimate is a range of possible value for a population parameter. Okay. I will give you the example for this. For example, I have the actual population like 29, okay, and I will get the interval estimate for this one is from 20 for 30. Okay, mu will from 20 to 30. That is called the interval estimate. Okay, I will give you the interval for this. That is the interval estimate. Or I will get you mu will from 25 to 41, something like this. So that is the interval estimate. Clear, right? Okay. That is the interval estimate. That is the range of possible value for the population parameter. If you know the interval estimate for the population mean, you can know that means that the actual population mean will be belong to this interval. Okay. That is the interval estimate. Any question? Okay. And we have two more concepts about the interval estimate. That is the level of confidence. Okay, the level of confidence or the confidence interval. Okay, what about this? The level of confidence is the percentage of all possible samples of a given size that will produce an interval estimate that contain the actual parameters. Okay, I will give you the example for this. For example, you see that the mean here is 29, right? Okay, and when I use the when they set that 90% confidence interval, right? 90% confidence interval, and for example, we will get 10 interval for this. That means that if we have 10, and we order the 9 out of 10 will contain the actual parameters, will contain the population mean. Okay, as you can see in the picture, only the fifth interval does not contain the actual population mean. Okay, that's the meaning of the confidence interval. If we have 90%, that when we have 10 interval, we will get 9 interval contain the population mean. Okay. And regarding the confidence interval, the confidence interval is an interval estimate associated with a certain level of confidence. Okay, I will discuss how to find this in the next part of my lecture. Okay, I give you the example for this. Okay, the example one you can see on your handout when you look at the. Now I just need you to determine which is the confidence level and which is the confidence interval. Okay. Here an example. A random sample of 10 colleges from Kiplinger's 100 best value in public education were taken. Okay. And they said that 95% confidence interval for the mean admission rate for this interval. Okay. And the rate of admission were normally distributed. And the question is, which of the following statement is the correct interpretation of the confidence level, and which is the correct interpretation of the confidence interval? Okay. So could you tell me which is the confidence level and which is the confidence interval in this example? Okay. When you look at the statement here. Okay. What about Y? What about I? Okay. What about I? Could you tell me in this statement, this is the confidence level or confidence interval? Okay, Mackenzie, please.
Interval?
Yeah, exactly, interval, because it's from this number to that number. So this is the confidence interval. Thank you, Mackenzie. Okay, and the second one, this is the confidence interval or confidence level. The number here is 95%. Okay, Delaney.
Confidence level?
Yeah, exactly. Okay. Thank you. Okay, that's all about the concept about the estimator. Okay, so now we will move on to the section 2, which play a crucial role in this chapter. Okay. Chapter 2, I will give you the method to estimate the population mean. Okay. In this chapter, we will focus on two kinds of estimation. The first one, we will focus on how to estimate the population mean. And the second one, we will focus on how to estimate the population proportion. And in this section, we will focus on how to estimate the population means. Okay, if you don't have the handout, please get on this. Okay, before I move on to the method, I will give you the condition to apply this method. Okay, condition to apply this method. What? Okay, when you look at your handout, you have 3 conditions to apply this method. Okay, we have 3 conditions. Okay, the first one, all possible samples of a given size are chosen using the random symbol method of sampling. We'll talk about this in chapter, I remember, chapter 2 or chapter 3, something like this. What about this? What is random sample? That means that every people or every member in the group are equal. For example, when I want to survey students, or when I want to survey people who like eating chocolate, right? I cannot go to the chocolate shop and I ask them, do you like chocolate? I cannot do that, because when I do that, I will get the NBS, the sample, right? Because people go to the chocolate shop, they often like chocolates, right? So I will, instead of doing this, I will ask every people on street, something like this. That is the random sample. And the previous way I told you that this is convenient symbol, convenient method. Like this, you can look at the chapter 3. I remember that I talked about this, and we had to use the symbol random symbol. That means every member here, the chain to choose is equal, something like that. That is the symbol random symbol. And the second one, the population standard deviation sigma is known. Okay. In this method, we need to know the standard deviation. If we don't know the standard deviation, we cannot apply this method. Okay. Sometimes they will give you the standard deviation in your question, something like that. And the sample size will be at least 30. At least 30. If the sample size very small, like 10 people, something like that, or 20 people, you cannot apply this method. It needs to be at least 30. At least 30. If you don't have the sample size like this, the population distribution is approximately normal distribution. We have 3 conditions like this. Clear, right? That is 3 conditions when you apply this method. If you don't have 3 conditions like this, you cannot apply this. Okay? That is condition. And what will we get if we have the condition like that? What will we get from this? Okay, we will get 3 things if we have these conditions. The first one, that is the best point estimate. Okay, the best point estimate for the population is the sample mean. Okay, for example, when I survey a student at West State University about the GPA, okay, I just focus on some sample, and I will calculate the sample mean of these sample. And after that, I will get the point estimate for the population mean. I don't need to measure all the GPA of students at West State University. That's it. Okay, to calculate or to estimate the population mean, you only need to estimate the sample mean. Okay, question?
I'm sorry to interrupt, but is there like a thermostat in here that we can turn down? Like, can we turn down the temperature in the room or anything? Do you know if that's possible?
I want to turn down the temperature, but I tried, but I cannot do it.
Okay.
I feel very hot now, but I don't know how to do that. Sorry. Okay. Okay. Any question about the lesson? Okay. If you know about sample mean, you can tell that the population mean is the sample mean. Okay. Approximately the sample mean. And the second one, we can calculate the margin of error or maximum error of estimate. What is about the margin of error? What about the margin of error? Okay, assume that I have the point estimate like this here. I have a point estimate right here, and the margin of error is the largest possible distance from the point estimate to the largest the largest bound. If I have E is the margin of error, so I know that the maximum value is the upper bound, and I know the minimum value is the lower bound. For example, if I have the point estimate of mu here is 29, for example, is real population mean, and I have point estimate here is 28 for something like that, and assume that I have E here is 5, and I know that the distance from the point estimate to maximum value here is 28 plus 5 is 33, right? And I know that the minimum value here is 23. So that means I will get the estimate from 23 to 33. If I know about the margin of error. Okay. If I know the margin of error, I can get the interval for the population mean. Interval estimate for that. Okay. So that is very important. Okay, if you know that, we can calculate. And how do we calculate this? I will discuss in the next part. And the third one, we can find the confidence interval for a population mean. Okay, how we do this? How we do this? We will discuss later. Okay. Okay. And okay, now we will focus on how do we find E? How do we find the margin of error? Okay, you can look at your handout and you see this is the formula to find the error, the margin of error. Okay, so E here will be calculated by this formula time to sigma square over square root n. Okay. This is the crucial formula. And what is the z alpha over 2 here? And what is about these numbers? Okay, z alpha over 2 here is, okay, you can see in your handout, z alpha 2 is the critical value. What is critical value? Okay, critical value. Okay, critical value is the area under the standard normal distribution to the right of z alpha 2 is equal to alpha over 2. Okay, this is very complicated. Okay, when you look at this, so to find z alpha over 2, you don't need to focus. You don't need to care about this. You will look at on the table 8.1. Okay, I also give you the table 8.1 for you here. So it will help you to find z alpha over 2. Okay, table and 8.1 is the critical z values for confidence interval. If you know the level of confidence, you will know the z value for confidence interval. For example, if you know the level of confidence is 0.8, what is the critical z value for this? Could you tell me? If you know the level of confidence is 0.8, what is the critical value for this? Okay, lead please.
Is it 1.28?
Yeah, exactly. Yeah. Okay. So that is the way to find the z alpha over 2 or critical value if you know the level of confidence. Okay, very hot today. Okay, so I will tell them about this. Okay. And okay, that is the way to find the z value if you know the level of confidence. Okay. And okay, and now we will focus on some example to solve some problem about estimation. Okay. We will look at the example 2 on your handout. Okay. You can look at on the screen. The researcher want to estimate the mean electric bill in a large urban area using the sample, a simple random sample. Okay, that is the first thing. Okay, they use the simple random sample method to do the survey. Okay, so that satisfy the condition, right? The first condition. And they survey 100 households. That means the sample size here is 100, right? It's greater than 30. So it satisfies the condition to apply this method, right? Okay, we have two conditions to satisfy. And they give you the population standard deviation is 15.5. Okay, they also give you the standard deviation about this. So it satisfies three conditions about the to apply this method. You can see here we have three conditions are satisfied. And the question here is find the margin of error for a 99% confidence interval. Okay, how to do this? Okay, the first thing we need to write down the formula for the margin of error here. That is z alpha over 2 over sigma square root of n. Okay. So they give you the the C here, the confidence interval here is 99%. That means that they give you the confidence level is 0.99. So could you tell me what is the Z, what is the critical value for this confidence level? Could you tell me what is the critical value for this? Okay, Arthur.
2.575.
Oh, 2.575, right?
Yeah.
Okay, thank you. Yeah, exactly. Arthur. Okay, we have the Cm over 2, right? Okay, and now we have sigma here is, okay, we have sigma here is 15.5, right? And the sample size here is 100. Is it clear? That's the all information. And after that, we will find E here. Just relate them. Just relate these numbers. Okay, it's the 2.575 times sigma here is 17.5 over square root of n, and here is 100. Okay. And after that, you will use calculator, and you will get the value here is approximately, okay, 2 decimal places, right? Okay, so it's 3.99. This is 3.99. That is the way to find the margin of error. The margin of error will help you to find the interval estimate for the population mean. Okay, so that is the first step when you want to estimate the population mean. Okay. Any question? Okay. So now we move on to the next example. You can look at on your handout, example 3. Okay, so in order to estimate the number of calls to expect a new suicide hotline, volunteers contact a random sample of 35 similar hotlines across the nation and find that the sample mean is 40 calls per month. Okay, the first thing you will need to analyzing, step 1, analyzing the question. What about this? When you analyze the question, that means you need to list all the assumptions of the question. Okay. They give you the volunteer contact a random sample of 35 similar hotlines. What does it mean? What does it mean here? Could you tell me what does it mean here? They contact a random sample of 35 similar hotlines. Okay, Tyler, right?
Yeah. Is it that they can do it because it's over 30?
Yeah, exactly. Okay, that satisfy the condition. Okay, thank you. Tyler. Okay, they give you 35 is greater than 30, so you can apply this. Okay, thank you. And also the information here is the sample size is 35, right? Okay, so it's greater than 30, so you can apply this. And find that the sample means is 40 calls per month. Okay, so the sample mean here is 42. Okay, 42. And construct a 95 confidence interval. So you have the confidence interval here is 95%. That means 0.95. and assume that the population standard deviation is known to be 6.5, right? 6.5 core per month. So the standard deviation here, okay, sigma is 6.5. Okay. So that's all information about the question, right? They give you all the assumptions like this. Okay. So how do we find the estimate for population mean? Okay, we have these steps. The first step, I will give you the step for this. To find the to estimate, you need to do the step like this. The first step here, to find the point estimate. This is the first step. That is the first step, find the point estimate. And the step 2, you will find the margin of error. Or phi E. The step 2, step 3, you will find the confidence interval. The confidence interval should be the point estimate from the, okay, I will tell you later about how to find the confidence interval. Okay, so now we will do step by step. Step 1, find the point estimate. Okay. Okay, you can look at the what we will get in the section 2A here. If you have 3 conditions are satisfied, what we will get? We will get the test point estimate for the population mean is the sample mean, right? Okay, so now you can see that the point estimate here is exactly the sample mean. The sample mean here is 40, right? Okay, that is the point estimate. Is it clear? That we apply the condition here. If it satisfies 3 conditions, so you can imply that the point estimate here is 42. 42. Okay, that is the step 1. Step 2. Step 2, we need to find the margin of error, phi E. That means phi E. Okay, and phi E here is calculated by this formula. Okay, so they give you the confidence interval is confidence level is 95%. That is 0.95. So could you tell me what is the critical value here? What is critical value? If they give you the level of confidence is 0.95. You please. Sorry, can you say it again? 1.96. Okay, what's your name, please? JV. Okay, JV. Okay, thank you. Exactly. That's the 1.96, right? Tom. Okay, we have sigma here is 6.5, and n here is 35. Okay? And when we do this, so we will get the answer for the is approximately 2.15. Okay, but we're not finished here. We just finished step 2. So now we move on to the step 3. Find the confidence interval. To find the confidence interval. Okay, to find the confidence interval, you notice the point estimate is the middle. And the distance from point estimate plus E is the upper bound. And the distance from point estimate to the lower bound is also E. That is the minimum value and maximum value of the population mean. Okay, so the lower bound here is equal to x bar, okay, because the point estimate is x bar minus e, right? X bar minus e is 42 minus to this number, so it's approximately 39.8, okay? And the upper bound is x bar plus e. The upper bound should be approximately 44.2. Okay. When you have this, when you have the lower bound and upper bound, that means that the population mean will from 39.8 to 44.2. Okay, that we get the interval estimate for the population mean. The population mean will belong to this interval. Is it clear, guys? Okay. Okay, that's the three steps to find the estimation for the population mean. Okay. Any question? Oh. Okay, we will do one more example for this. One more example for this. You can look at the example 4. Okay, we also have the analyzing step when you do the question. A toy company wants to know the mean number of new toys per child bought each year. Marketing strategists at the toy company collect the data from a parents of 1842, randomly select the children. So, what is the meaning of this number? What is the meaning of this number 1842? What is the meaning of this? They give you, with the information they give you. They give you information about 1842 randomly selected children. What does it mean? What does it mean? Example 4. That means they give you the sample size, right? They give you the sample size. The sample size here is this number. And the sample mean is found to be 4.7. That means they give you the x bar here is 4.7. Okay, and they give you the 90, the confidence level is 90%. Okay, and they give you the population standard deviation. Sigma here is 1.9. Okay, so all information. So you do similarly. You 3 steps. Step 1, find the point estimate. Step 2, find the margin of error. Step 3, find the confidence level, confidence interval. Okay. So now, what is the point estimate? What is the point estimate here? What is the point estimate in this example? Okay, you please. Yeah, exactly. You mature. Okay, exactly. When you have 3 conditions satisfied, so the point estimate is exactly the sample mean, right? So the point estimate is the sample mean here is 47. Sorry, 4.7. And the step 2, we need to find the margin of error, right? Find the margin of error. We will apply this formula. Okay. We will find the. We will find the top. Okay. So could you tell me what is the critical value in this case? They give you the confidence level. So could you tell me what is the critical value in this case? Use table to find this. They give you the confidence level is 0.9. So could you tell me what is the critical value? No. You can use the table 8.1. So the level of confidence is 0.9. So the critical value for this is 1.645. Okay, that is the critical value. It is using the table 8.1. Okay. And after that, we lay sigma here is 1.9 square root of this number. Okay. And after that, you will get the result here is 0.007, right? Okay, that is step 2. We have the margin of error. Any question? To find the margin of error, just replace the number. And after that, when you know the margin of error, you can find the lower bound by using formula x bar minus the margin of error. The point estimate 4.7. So you minus to this number. Okay. So you get the value should be nearly 4.6. Okay. And the upper bound should be point estimate plus to margin of error should be 7.8. So the interval estimate for the population mean will be from 4.6 to 4.8. Okay. Is it clear? That is the way to find the interval estimate for the population mean. Okay. Any questions? So you can try to do some practice exercise here. I provided here to practice. Okay, now I will make some attendance for you. Max here, not here. Oh no, not here. Laurel, Davia here, Kylie not here, Bobby not here, Christopher, Chris Dollars not here, Cherry, Robin, Bender Grossinger, Abdul Nick not here, Sherman Peters, Kipling, Dick here, Ordila not here, Alondra,
Here.
Matthew here, Tyler here, Alia Smith, Yassi not here, Sullivan, Thomas not here, Ria Wadley, Tyler not here. Okay, thank you for your attention. So see you on Wednesday.